Hi everyone, we're going to use this video today to go over some of the things that Mr. Terry talked about in his video, and I will also help you work through some of the examples on the worksheet that Mr. Terry asked you to complete today. So let's get started. Did you guys know that we can write 1 in many ways using fractions? Let me give you an example. The fraction 1 over 1 is equal to 1. The fraction 2 over 2 is also equal to 1. The fraction 3 over 3 is also equal to 1. And I could keep going. Let me explain to you why this works using our understanding of division. If I have 2 friends and 2 apples, and I want to share my apples equally amongst my friends, I would give each friend 1 apple. So here are my 2 apples divided equally amongst my 2 groups of friends. Each friend gets 1 apple. When fractions have different numbers in them but have the same value, they are called equivalent fractions. Let me give you an example. The fraction 1/2 and the fraction 2/4 use different numbers, right? The numerator and the denominator in 1/2 is different than the numerator and the denominator in 2/4. So even though these fractions use different numbers, they actually represent the same value. And I'm going to show you what I mean by using my fraction circles. So here is my fraction 1/2. And here is my fraction 2/4. You can see that 1/2 and 2/4 represent the same size part of the whole. So these fractions are considered equivalent fractions. They're equal. So last week we talked a lot about how we can find equivalent fractions using our fraction circles, using our number lines, and using our fraction strips. But equivalent fractions can also be found by multiplying both the numerator and the denominator by the same number. The reason this works is because when we multiply any number by 1, we get that same number. Let me give you an example. 6 times 1 is equal to 6, that's right. 3 times 1 is equal to 3. 800 times 1 is equal to 800. That's right. So we multiplied each number by 1, and every time we got the same number. This rule is the same for fractions. The only difference is that fractions look different than whole numbers. Remember when we said earlier that 2 over 2 is equal to 1 and 3 over 3 is also equal to 1? So if we take our fractions 1/2, okay, and we were to multiply that fraction by 2 over 2, that would really mean that we're taking 1/2 and we're multiplying it by 1. When we multiply fractions, we multiply straight across, starting on top with the numerators. So 1 times 2 is equal to 2, that's right, because any number times 1 is equal to that number. And then 2 times 2 is 4, right? You can always skip count by 2's, 2, 4. So what this is telling us is that 1/2 is equal or equivalent to 2/4. And we can check that using our fraction strips. So here's 1/2, and here's 2/4. They are equivalent because they represent the same size part of the whole. So as long as we multiply the top and the bottom of a fraction by the same number, it's just the same thing as multiplying the fraction by 1, and we won't change the value of the fraction. We won't change how much of the whole the fraction represents. Let's practice one of the examples that Mr. Terry asked you to complete on the worksheet together today. So on your paper in front of you, I would like you to write down the fraction 1/3. Okay? What Mr. Terry is asking us to do today is he is asking us to multiply the fraction 1/3 so that we can find a fraction that is equivalent to 1/3. Let's practice multiplying our fraction 1/3 by using the fraction 2/2. Remember, when we're multiplying a fraction like 1/3 by a fraction like 2/2 with the same numerator and the same denominator, it's just like multiplying this fraction by 1. So a trick that I learned today is to draw a number 1 around, and that's not a very good number 1, but to draw number 1 around my fraction 2/2 to remind me that 2/2 is the same thing as saying 1/2. So let's multiply these fractions together. 1 times 2 is 2. Good, because any number times 1 is itself. And 3 times 2 is, well, let's skip count by 2, because 2 is an easy number to skip count by. Let's skip count by 2 3 times. 2, 4, 6. Excellent. So what this is telling us is that 1/3 is equivalent to 2/6. And I'm going to write that down here so it's a little easier to see. So 1/3 is equal or equivalent to 2/6. And I am going to take my fraction strips out, and I'm going to check to make sure that 1/3 is equivalent to 2/6. All right, and there you have it. So I'm going to erase this, and I would now like you on your paper to write down the fraction 1/4. Okay, your job is going to be to pick a fraction that you want to multiply 1/4 by. So remember, you can choose any fraction that's equivalent to 1. So maybe you'd like to do 2/2, or maybe you'd like to do 3/3, or 4/4. It doesn't matter. You can choose any fraction as long as it's equal to 1. And remember, for a fraction to be equal to 1, the numerator has to be the same as the denominator. So when you're ready, you can go ahead and pause this video, and you can pick a fraction that you would like to multiply 1/4 by to get your equivalent fraction. Then you can use a number line, your fraction strips, or your fraction circles to check to make sure that your two fractions are equivalent. When you're done solving that problem, you can go ahead and press play again. Okay, friends, great job. Those are the only 2 multiplication questions that I'm asking you to complete from Mr. Terry's sheet. Let's move on to division and do 2 division problems together today before we stop. So, just like with multiplication, we can also use division to find equivalent fractions. When we divide a fraction, we are taking a fraction with a larger numerator and a larger denominator, and we're going to divide it by 1 to find an equivalent fraction. So let me write that down so it makes a little more sense. So I'm going to write down a fraction with a numerator and a denominator. I am then going to divide my fraction by 1. Now remember, we're working with fractions. So I'm going to divide my fraction by another fraction that's equal to 1. Okay? I'm going to use 2/2 today to divide my fraction. So 2/2 I'm sorry, 2 over 4, 2/4 divided by 2 over 2 is equal to, well, let's see, 2 divided by 2 is equal to 1, right? If I had 2 friends and 2 pieces of candy, I'm going to divide the candy equally amongst my 2 friends, okay? And 4 divided by 2 is, it's 2, right? If I have 2 friends, okay, and 4 pieces of candy, I'm going to give each friend 2 pieces. Okay, so you can always draw a picture to help you if you're unsure of your division fact. So, you'll notice that we started with a fraction that had a larger numerator and a larger denominator. And when we divided it by our fraction, 2 over 2, which is the same as 1 whole, we got an equivalent fraction with a smaller numerator and a smaller denominator. So what this is telling us is that 2/4 is equal or equivalent to 1/2. And we've actually used this example many times tonight, but we can check it again. So 2/4 is equivalent or equal to 1/2. So even though these pieces are smaller, when we have the 2, it's equal or equivalent to our 1/2. Okay, so just like we did with the multiplication problems, I am going to ask you to solve the next one on your own. So we're going to do 5/10. So I'd like you to go ahead and write down 5/10 on your paper. You are then going to divide 5/10 by a fraction to find an equivalent fraction. When you're dividing 5/10, you want to look for a fraction that has a numerator denominator that can be divided by 5 and 10. So if you tried 2 over 2, you have to think to yourself, can I divide 5 divided by 2? 3 over 3, can I do 5 divided by 3? If I had 5 friends and I had 3 pieces of candy, can I equally share that candy amongst my 5 friends? That's not going to work. So maybe you could try 4 over 4 or 5 over 5. So you have to find a fraction that you can use to divide, 5/10 by. So when you're ready, you can go ahead and pause the video and work through the rest of this problem. Friends, as you can tell, this is a really, really tricky topic. I'm proud of you for working hard and trying your best. Once you finish this problem, those are the only 4 problems that I'm going to ask you to work on today from Mr. Terry's sheet. Okay, great job, guys.